In this video, we're going to look at one-step equations and how to solve them by adding and subtracting. All right, let's start by reviewing what an equation is. An equation is a mathematical statement that two expressions are equal in value. So if we think of a pan balance, we have the left side and the right side of our pan balance. And for our balance to be equal, the left side has to weigh as much as the right side. So in order to work with equations, we always have to maintain that it is a true statement and that the left side equals the right side. So whatever you choose to do to the left side, you have to do to the right, and vice versa. Whatever you do to the right side, you have to do to the left. Our goal in solving all equations is to isolate the variable on one side of the equation. And it doesn't matter if it's one-step, two-step, or multi-step equations. Our goal is to always isolate whatever variable we're solving for on one side of the equation. So what does that mean? So here's an example of an isolated variable. If you notice, the x is on the left side of the equation and everything else is on the right. In this example, where variables are not isolated, my x is on the left side of the equation with the number 5. It is not isolated. It is not alone. The key to solving any type of equation, whether it's one-step, two-step, or multi-step equations, is we're going to solve using inverse operations. So inverse operations are operations that undo each other, and we use them to isolate the variables onto one side of the equation. So inverse operations, or the operations that undo each other, addition and subtraction, are inverse operations. For example, 4 plus 3 equals 7, and 7 minus 3 will equal 4. Addition is undone by subtraction. The other type of inverse operations, or set of inverse operations, is multiplication and division. They undo each other as well. So for example, 3 times 4 is equal to 12, and 12 divided by 4 is equal to 3. They are also inverse operations. All right, let's look at one-step equations and using the subtraction property of equality. And what the subtraction property of equality says is that subtracting the same number on each side of an equation produces an equivalent equation. So we have the equation x plus 9 equals negative 10. I need to isolate the x, and in order to do that, I need to get rid of this, and let's think of it as a positive 9. Now the opposite of a positive 9 is a negative 9. So using the subtraction property of equality, it says I need to subtract 9 from both sides. That's also going to keep my equation balanced. Now what happens when I subtract from both sides? My 9's will cancel out because a positive 9 plus a negative 9 is 0, and that just leaves me with x on this side of the equation. And then I do this other math problem on the other side. I have negative 10, and if you want to think of it as addition, I have negative 10 plus negative 9 equals negative 19. Now I can check this to make sure if I am correct by plugging in this negative 19 into the original equation for the value for x. So that's where my check step comes in. Here's my original equation, x plus 9 equals negative 10. I plug in negative 19 for x, and now if I do the math on this side of the equation, a negative 19 plus a positive 9 is a negative 10. The left side of my equation matches the right side of my equation, so then this is a good solution. Okay, let's look at the addition property of equality, and that says adding the same number to each side of an equation produces an equivalent equation. So I start with the equation, negative 8 is equal to y minus 15. And notice now this time my y is on the right side of the equation. We shouldn't be afraid of that. We just need to learn how to work with it on either side. So I need to isolate my y which means I need to get rid of this negative 15. And the opposite of a negative 15 is a positive 15. So using the addition property of equality, if I add 15 to the right side of my equation, I also have to add it to my left side of the equation. And notice I put these little summation bars. That's so I'm implying that I'm adding these together. So a negative 15 plus a positive 15 would equal 0. So these actually cancel out. And then if I look at my other little summation problem, I have a negative 8 plus a positive 15, and 15 minus 8 would be a positive 7. So y is equal to positive 7. Now, checking to see if that is the correct answer, I rewrite my original equation. Negative 8 is equal to y minus 15. And for y now, I'm going to plug in that 7. And then I'm going to do my math. I have 7 minus 15 is negative 8, and that my left side now equals my right side, so I've checked it and my answer is correct. All right, let's preview how to solve multi-step equations. So in this example, I have 2y minus 1 minus y equal negative 3. So I need to look at my variables, and I have a negative y here and a 2y. And if you want, you can go in and you can do change, if that helps. Let's do change. So I know from combining like terms that I can add my 2y and my negative y together and make it one term. So I rewrote it in this second step, and I have 2y minus 1 equal negative 3. So let's just look at these right now, these terms. I have 2y, and we'll do change, and this becomes a negative, and let's put a 1 in there, because when there's no coefficient there, we know it's a 1. So I have 2y plus negative 1y, and 2y plus a negative 1y would equal a 1y, or 2 plus a negative 1 is equal to a 1. So that's where this comes from, this y. So this is a 1y. And then I just bring down everything else I've not touched yet. I have a negative 1, I have a negative 3, and now I have a one-step equation. And the opposite of a negative 1 is a positive 1. So I add a 1 to both sides. These negative 1 plus positive 1 will cancel out and leave me with a y on this side. And now I take negative 3 plus a positive 1 is a negative 2. And that is solving a multi-step equation.